A major issue, which might have occurred to you but we haven't talked about yet, is that with frequentist statistics, we have this problem of multiple comparisons. So if you perform 20 statistical tests where there is no real effect, so the null hypothesis is true, then we would expect one of those 20 to come up as significant by chance alone. So that's what we call a false positive or a type 1 error. If you perform 100 tests in such a circumstance where there's no real effect, then at that standard alpha of 0.05, that significance threshold of 0.05, you would expect 5 false positives now. So this kind of problem becomes much, much bigger in the machine learning world, in the computing world, where we can trivially, easily run for loops or algorithms that do hundreds, thousands of comparisons, and we'll get tons and tons and tons of false positives if we stick with that standard alpha 0.05 threshold. So the most straightforward and indeed the most widely used solution is the Bonferroni correction, which is named after the 20th century Italian mathematician Carlo Emilio Bonferroni. So assuming that over all of the tests that you're performing, you'd like an alpha of 0.05, a significance threshold of 0.05, then if you're planning on conducting, say, 10 statistical tests, so m is equal to 10, then the significance threshold for each test is simply that alpha of 0.05 divided by m, which is 10. So that gives us a new statistical significance threshold of 0.005. So now, if on any of those 10 tests, we get a p-value that's less than 0.05, that's no longer good enough. It actually needs to be below 0.005 for us to say, hey, that is statistically significant. And the more tests that we're running, the lower that p-value threshold becomes for any individual test. So if you have 20 tests, all of a sudden it's 0.05 divided by 20, which is 0.0025. That's your significance threshold. And with 100 tests, it becomes 0.0005. There are other less straightforward approaches for adjusting alpha for multiple comparisons. They're beyond our scope, but the major ones are listed under the General Methods of Alpha Adjustment for Multiple Comparisons heading here on this page. Nice, so now we have a good handle on how to compare the means of different distributions, of how to look for correlation and causation between variables. Up next, we're going to dial everything up a notch by going into detail on regression, which allows us to try to predict an outcome based on one or more input variables. I'm looking forward to digging into that with you.